This is the 5-4 to 5-5 review. Calculators still are not allowed. I'm expecting you to do these things by hand. And the question is, which of the following are antiderivatives of 1 over x times the ln of x? Well, in order to be an antiderivative, that means if you take the derivative, you should get that 1 over x times ln of x back. So we're going to test each of these by simply taking the derivative. If I take the derivative of this, I can move through the constant, which is a third. Then I hit the power, so I'll bring that down and have an ln of x squared, and then I'll multiply by the derivative of the inside, which will be a 1 over x. And that does not look like it is going to simplify to give me this. So no, A does not work. If I look at B, again, I will take the derivative of that. And that's going to require my quotient rule. So I'll have low times d high. I'll move through the constant, hit the power, inside unchanged raised to the second times the derivative of the inside. Low d high minus high d low all over low squared. Well, that does not look very likely, so I'm going to guess that no, that is not going to simplify down to that. I got too many other constants running around and powers of log natural that are on the top. I don't have any log naturals on the bottom, so I'm not going to waste more time on that one. Let's look at the next one. C says if I take the derivative of that, then I will pass through the constant, so that's a 0 because the derivative of constant is 0, plus what I hit first here is the log, so that'll be 1 over the inside. Then I need to multiply by the derivative of that inside. Oh, now this one's looking a little better. That one seems to be a true antiderivative of what we wanted, so C is one that works. If I look at the next one, wow, I see that I'm going to have to do quotient rule, which I'm not too happy about. So what I'm going to do instead is I'm going to rewrite this as a negative ln of x to the negative 1. And then I'm going to take the derivative. So that'll give me a positive 1 times an ln of x to the negative 2 times a 1 over x plus a 1. Now that one, since it's got a log on the bottom, might be a contender, so I'm going to take it just a little bit further. That would give me a log natural squared times an x on the bottom of the first term plus a 1. No, that's not going to give me a single log natural on the bottom, so D is not going to work. Okay, let's look at the final one. Well, the final one, again, I've got a quotient rule going on, which I don't really like, so I'm going to change that to the derivative of a 3 minus a log natural of an ln of x to the negative 1. And before I take the derivative, I'm going to say, hey, wait a second, if I have interior powers on a log, that's the same as an exterior coefficient. So I'm going to rewrite that as the derivative of a 3 plus an ln of x. Now that one looks an awful lot like the one I just did in C. It's just off by a constant, so I think it's safe to assume that the derivative of that one is going to be the same as the derivative of the one where I was adding 2 instead of 3. So the two that work are C and E.